Hi everybody, happy Friday. Today we're going to be learning about Newton's third law, and our target is to apply Newton's third law to everyday life. Specifically, I'm going to be taking an example from my own personal life and applying that to Newton's third law with you guys to help you guys understand how Newton's third law works and also to see how it benefits us in our lives. One thing that I will be using today is Newton's second law. So if you haven't watched my video from Thursday on Newton's second law, you should watch that because I'm going to be using Newton's second law alongside with Newton's third law to explain this real life example that I want to talk to you guys about. Okay, so first things first, what is Newton's third law? It's fairly straightforward. Newton's third Newton's third law basically states that for every action, there is an equal and opposite reaction. You cannot touch something without it touching you. If I push on a dresser, the dresser pushes back. If a car accelerates down a road, it exerts a force on the road, and the force exerts a road on the car. I know those were a lot of really fast examples, so I'm going to take a little bit of time and work through you guys with an example that's a little bit more thought out. Okay, so once you guys become 16, you will be able to drive a car. You can get a license. In fact, when you're 15, you can get a permit. I didn't actually start driving until I was 17. So I was a junior in high school when I started driving. I passed my license test first time. Very proud of that. And I learned some really important lessons that I wish I didn't have to learn the hard way. So, for every action, there is an equal and opposite reaction. When I was in 11th grade, I was driving my car in the winter on my way to a saxophone lesson. And there was a lot of ice on the road. Now, it was tricky because in Minnesota, we get something called black ice. And it's called black ice because the ice is clear. And so it shows the asphalt and the cement underneath it. And it looks like that ice isn't actually there. Okay. So I was about to make a turn on a road when my car hit some black ice. And in front of me was a really big tree. So I turned the wheel of my car, and the wheels on my car turned, but because I didn't have any friction, my car kept moving closer and closer towards the really big tree. Now, cars are really interesting because of Newton's second law. So remember, Newton's second law states that the force an object exerts equals the mass of that object times its acceleration. Are cars big? Yeah, cars are pretty big. Try and lift a car, right? You won't be able to. Cars have a lot of mass. Let's just call it 100 for right now, keeping our numbers simple. 100 kilograms of mass. It's way more than that. It's honestly, you know what? Let's be more realistic. It's more like 10,000 kilograms. Okay. I was driving too fast. I was driving way faster than I should have. I was an inexperienced driver. I was young, and I hadn't learned the lessons that I was about to. I was moving at about 50 meters per second squared. So, using Newton's second law, I can use this to try and figure out what my force is, right? How much force is my car currently exerting? Well, if the mass equaled 10,000, let's just get rid of a zero just to make the math a little easier. If my car had a mass of 1,000 kilograms, which it didn't, it had way more, and it was moving at a speed of 50 meters per second squared, then if we use our handy dandy little calculator, 1,000 times 50 is 50,000 newtons of force. And remember in our video yesterday, we were talking about things having like, high, small, medium amounts of force. 50,000 newtons of force is a lot. So why does it matter? Well, because in about 2 seconds, my car was going to hit a really big tree, with 50,000 newtons of force. And that's where Newton's third law comes in. See, for every action, there's an equal and opposite reaction. So I was going to hit that tree with 50,000 newtons of force. And that tree, here, let me get a little different tool. That tree was going to hit me back just as hard with 50,000 newtons of force. My car crumpled. We had to get a new hood. There was a little bit of damage to the engine. Fortunately, I was okay. But I kid you not, that was the scariest moment in my life. I could have died. If I had been going a little bit faster, or if my car had hit that tree in a different way, or if I had barrel rolled, cars are scary dangerous. I'm not saying this to tell you guys that you should never drive a car. Cars are really useful, and honestly, being able to drive a car is one of the most freeing experiences ever. A lot of people really enjoy driving. But it's dangerous. You can get hurt. And so, as you guys grow older and you start to drive cars, just remember, for every action, there is an equal and opposite reaction. Cool. Stay safe, stay healthy, stay happy. I'll talk to you guys later. See you later. Bye.